You hear the word data everywhere, right? Big data, data science, data privacy. It's called the new oil, the lifeblood of AI. But what does that actually mean? What is data, really? Well, that's what we're here to figure out. It seems like such a simple question, doesn't it? But the answer, well, it's surprisingly deep. And honestly, it's crucial if you want to understand the tech that shapes pretty much everything we do. So let's cut through all that jargon and get right to the heart of it. All right, so here's our game plan. We're going to start with a simple definition, then look at the two big ways data is categorized. After that, we'll see how it becomes meaningful, how it's used in tech, and finally, we'll touch on the really important ethical questions. Let's dive in. Okay, first things first. Let's move past the buzzwords. At its core, data is actually pretty straightforward. It's not some kind of magic, it's just the starting point for pretty much all knowledge. So here's the basic definition. Data is just a collection of facts, figures, symbols, you name it, gathered from all over the place. Think of it like raw ingredients, right? It's the unorganized stuff, numbers, words, pictures, sounds, before we've actually done anything with it. And you've got to understand, data comes in so many forms. It is definitely not just about numbers on a spreadsheet. I mean, the words in an email you just sent, that's data. That photo you took on your phone, also data. A podcast you're listening to, yep, that's data too. It's literally the raw material of our world, both digital and physical. All right, so we've got all this raw stuff everywhere, but how do we even begin to make sense of it all? Well, the first step is to understand the two main ways we categorize data. And trust me, getting these two concepts down is key to everything else. So the first big split is actually pretty easy to grasp. It's really just, can you count it, or do you have to describe it? Quantitative data, that's all about numbers. Think quantity. Your height, the temperature, how many people are in a room. Qualitative data, on the other hand, is descriptive. Think quality. The color of a car, your opinion on a movie. One measures, the other describes. Simple as that. Okay, now for the second big divide. And honestly, this one is probably the most important one to understand in our modern world. It's structured versus unstructured. Structured data is super neat, right? It's organized. Think of a perfect spreadsheet where everything is in its own tidy row and column. But unstructured data, well, that's everything else. The best analogy is a messy shoebox filled with random photos, old letters, and newspaper clippings. It's just all over the place. And here is why that messy shoebox matters so much. A massive 80 to 90%, let that sink in, of all the data businesses and organizations deal with today is that unstructured kind. We're talking emails, social media posts, videos. This is where the biggest challenges are, but it's also where the richest insights are hiding. Okay, so we've got all this raw data, both neat and messy. But here's the thing. A pile of raw ingredients isn't a meal. On its own, raw data isn't really that useful. The real magic happens when we turn it into something meaningful, which brings us right to our next point. This step right here, this is the crucial transformation. Just look at this example. You see a list of numbers, 25, 30, 28, 32. That's data. It doesn't mean much, does it? But when we process it, let's say we calculate the average, we suddenly get information. The average temperature this week was 29 degrees. See? Now it has context. Now it has meaning. It's useful. So how do we actually do that processing and organizing? Well, one of the most powerful tools we have is something called metadata. It sounds complicated, but it's a really simple idea. It's just data about data. Think of it like the label on the outside of that messy shoebox. It tells you what's inside without you having to dig through everything. Yeah, think about any digital file you have, a document, a photo. The metadata is what answers all the important questions about it. What's its name? What's it about? Who created it? When was it made? Without this context, finding anything would be a total nightmare. Okay, I think we've got a really solid foundation now. So let's connect all of this to the technology that literally runs our world. How do computers actually take all this data and, do stuff with it? Right, so for a computer to work fast and not crash, it can't just have a jumbled mess of data in its memory. It needs to be organized in very specific ways using things called data structures. You can think of them like different kinds of digital filing systems. For instance, some data is organized like a stack of plates. The last one you put on is the first one you take off. Other data is organized like a line at a grocery store, first come, first served. These simple organizing principles are the building blocks for how all software manages information. And all of this leads us straight to the biggest topic in tech right now, AI. You can think of AI as this incredibly powerful engine, right? But an engine, no matter how powerful, is totally useless without fuel. And for AI, that fuel is data. And not just a little bit of it, massive, massive amounts. This brings up a super old but super important rule in all of computer science: garbage in, garbage out. It means an AI model is only ever as good as the data you feed it. If you train it on bad, incomplete, or biased data, guess what? You're going to get bad, incomplete, or biased results. It's really that simple. And the consequences can be massive. And that's exactly why data quality is so incredibly important. It's not just about having a ton of data. It's about having good data. You have to ask, is it accurate? Is it correct? Is it complete? Or are there big holes in it? Is it consistent so you're actually comparing apples to apples? These three things, accuracy, completeness, and consistency, they are the pillars that hold up any reliable AI system. Okay, so this brings us to our final section, and this might be the most important part of the whole conversation, because with all this incredible power to collect and analyze data comes a huge amount of responsibility. As we keep building this data-driven world, we have to face some really tough ethical questions. How do we protect people's privacy? Are people giving real, informed consent for how their data is used? How do we make sure the algorithms we build are fair and don't just reinforce the biases we already have in society? And when things go wrong, who's held accountable? And this quote really just nails it. At the end of the day, having the most sophisticated technology in the world doesn't solve these ethical dilemmas. What we really need is moral clarity. It's a fundamental commitment to being fair, respectful, and responsible with every single byte of data we collect and use. And so that leaves us with this huge question, one that doesn't have an easy answer. As our world creates more and more data every single second, who should be responsible for how it's used? Is it the companies building the tech? Is it the governments trying to regulate it? Or is it maybe all of us, since we're the ones creating and using this data every day? It's something we all need to be thinking about.